As we move on to topic 4 of chapter 8, here they're dealing with applications using quadratic equations. And the first 4 examples deal with speeds of things and distance and time. So we're using the distance formula. Distance equals rate times time. And if we divide both sides by r, we get time equals distance divided by rate. And that was something you needed to have in order to do the first 4 problems because they're all similar. And I have the equations up here, but I'll go through them with you. I'm not going to write them all out, but if you have a booklet, you can see how they go. It says during the first part of a trip, a person went 150 miles at a certain rate. Later in that same trip, that person went 90 miles, but at a 5 miles an hour slower rate. So the rate of the original, this many miles, a slower rate. And this took 5 hours. So we're saying that time is equal to distance divided by rate. So distance divided by rate, in a sense, this is t. Well, that's t sub 1 anyway. And this is also a t sub 2. And that's going to equal the total time. So this is a time, and it equals this total. Now, in doing this, you need to first be able to put what's written into an equation. And that's what I'll go over first. And then I'm going to go over methods of solving the equations, because that gets a little complicated too. All right, for example 2, here a person travels 300 miles at a certain rate. Then they went 300 miles at a 10 miles an hour less than they were doing before. So this is, in a sense, time. And this is time. But in the textbook, they're saying this part of the trip took 1 hour more. So there's time, and there's time. And we're saying this time equals this time. And again, we didn't solve the equation. All we did is put it into some sort of form. Number 3, again, we're using the same basic principle that this is time, and again, this side took 1 hour more, so that this time equals this time. And here for number 4, a person on a bike does this at a certain rate, does the return trip at a 48 miles is the same distance, but it's 2 miles an hour faster, and the whole trip. So this is sort of like part of the time equals the total time. Now, when you're doing word problems, once again, the strategy is you read it carefully, and they're not showing me the equations. All they're doing is telling me the answers, as we have in the back of the booklet. So you have to read the equations, the statements here carefully, and then carefully think of what strategy are you going to use, and then develop your equations. And then the next step is, how do you solve the problems? So let's do a little bit of that now as well. This is our strategy for getting the equations. Now our next strategy is to get rid of the fractions. And to do that, you have to multiply each of these fractions by the lowest common denominator, which happens to be r times r minus 5. And we can do it this way. Theoretically, you're putting this by each term. And let's follow through with this one a little bit here. So here the r's are going to cancel out. And then now this one's gone. So this is going to be, this is gone, canceled out. R times 150 is 150R. Now 5 times that is a negative 750. Now we're going to cancel this out with this one. So this leaves us with 90R. And now we have to multiply 5 times this, since nothing cancels out. So this is going to be, let's just do it up here, 5R then. Multiply this by that, gives me 5R times r minus 5. So this will be 5r squared minus 25r. Ah, you have a quadratic equation now. So now what do you do? Well, you need to move all of this over to one side here. So this is going to be 5r squared. I'm going to add this together and this together. And that becomes a positive 240r on this side that I'm going to now transpose. So over on this side it becomes a negative 265r. And then we're left with a negative 750 that we're going to transpose, and that becomes on this side a positive 750, and that equals 0. So what happens next? Well, I can see I can take a 5 out of each one of these. So I'm going to do that. And that's going to be then r squared minus 53r plus 150 equals 0. I just divided each of these by 5, as well as the 0. That still stays 0. So this gives me r squared minus 53r, and this gives me 150. Now you could put that into the quadratic formula, but as I looked at it, I said, well, wait a minute, that's factorable. So if you can see that it's factorable, factor it. That's a lot easier than the quadratic formula. Or completing the square. This one would be a real bear. So r, 50 and a 3. That's what I saw when I saw 150 and 53. I said, oh, it's going to factor. And these are both going to be negative. So what do you get for your answers? Well, here you get a positive 3 and a positive 50. Now, here's a case where you look at your answers and say, is 3 a reasonable answer? Well, here, if you had r a 3 minus 5, you're going to have a negative 2. You can't drive negative 2 miles per hour. So we reject this one. And then our rates then, this rate is going to be 50, and this rate is going to be 45. And those are the answers, I'm happy to say. Okay, well, again, part of it is setting up the equation. Secondly, converting that equation to an equation without fractions, doing all of this, and then once you get a quadratic equation in standard form, you can use the quadratic formula, or you can try factoring, or you can try completing the square. These are all methods that we've had. Actually, I'm going to stop it to erase this because it gets kind of confusing. And I'm just going to focus on what to do with converting these equations now into equations without fractions. So once again, what's our common denominator here? Think about it for a moment. And again, very similar to up here. It's going to be r times r minus 10. And as we multiply through, here the r cancels out, and we're left with 300r minus 3,000. That would be, once you've canceled out the r times 300, and then a negative 10 times 300 gives you that. Now here, you're going to cancel this out with this, so you're left with 300r, and then it's just going to be 1 times this, which becomes r squared minus 10r. Now I'm going to leave the rest to you, because you see how tedious it is to do it. And again, the answers are there. And r is 60 miles per hour. And number 3, again, what will be your common denominator? And it's going to be r times this. And you do the same thing as we did here to clear it. And over here, it's going to be r times r plus 2. Okay? Again, if I worked them all out, the tape would be very long. These are tedious. What my purpose is here is to show you the technique of doing it. Now actually I did work out another one too, number 3. So I'm going to do number 3 for you. but I'm not going to do it live. I'm going to put it up there because it is tedious. Okay, the numbers get quite large, and also I had a little error here. This is 75, not 15. I didn't see that too well. I should have made the European 7 there. But I caught it in time because I did the work correctly. So this is my common denominator. I cancel out the r's here. Then I multiplied this through and I got this for the, well, 1 times this gave me this. Then it was this times this, that gave me that. And then this canceled out, then I went r times that, and I got that. Then I brought everything over to the left. So I had an equation in standard form for the quadratic equation. Now actually this would factor. When I looked at it, I said, oh, I had no idea what the factors were. So I used the quadratic formula. So b is a negative 425. So since it's negative b here, this becomes a positive. Then plus or minus b squared, which is what I did, minus, I noticed in one of my tapes I forgot to put the minus here. Again, you got to check your work. There's lots of little places where you can make an error. And if you spot that, you let me know, I give you a bonus point. Negative 4 times a, which is 1, times c, which is this. Now, thank the Lord for calculators, because I just did this in my calculator, and then without taking the answer off, I just hit second function, square root, answer, and I found out that this is a perfect square, 175. So this becomes 425 plus 175 divided by 2 gave me 300. When I put the negative value in there, that gave me 125. And that's a viable answer as well. So that's why in your little booklets, in your answer key, it says the answers could be using the 300 as your R, adding 75 to it gives you 375. So this is one set of answers that would be perfectly okay and meet the requirements of this example. Or 125 plus 75 gives you 200, which is another set of answers. So each of these examples, as you can see, are going to take quite a bit of time. Toward the end of your class here, and you get some pretty challenging problems. Now, the nice thing about some calculators, if you're allowed to use it, you can just plug this in, and it gives you the answers. That's another good deal. As we continue with applications, and again, they're usually going to end up with some kind of quadratic equation. Number 5 is exactly as we did before, in which you have a river. Now the stream, of course, flows down, so that if you go upstream, you are going against the current. And it's saying this river flows at 4 miles per hour. And this person travels upstream 20 miles. And we don't know the person's rate. But since it's going against the current, current's going this way, he's going up against the current, it's going to be 4 miles an hour less than he drives up in his normal rate of the boat. And then he drives 20 miles down, the same amount of distance, but now he's with the current. So we're adding the speed of the current to the boat's rate. And remember, distance divided by rate, this is time, and it equals the total time of 3 hours. So that's the basic formula, except when you're going to get rid of the fractions, your common denominator is both of these. We'll get to that in a moment. All right, this is one that we did some of these earlier in the course. These are work problems where the rate of something is 1 out of what they do, 1 out of what they do, and then 1 out of the total. If you recall that if someone did something 1 in 5 hours, the other one did 1 in 4 hours, how much did it take if they worked together? Well, a little different in that here they're telling you that there are 2 pipes that are filling up a tank, and one pipe takes 15 hours less than the other pipe. So this other pipe is going to be T hours. This is going to be T minus 15 hours. That's the faster pipe, slower pipe. Together, they can get the job done in 4 hours. So it's 1 out of 4. So let's show our common denominators here, and then how to get rid of the fractions. So our common denominators are these two, r plus 4, r minus 4. They're conjugates, so that's sort of nice. And here, this one would cancel out, and you would then get 20 times r plus 4. This is going to be 20 times r minus 4. These cancel out now. And then here, this is going to be 3 times this, and keep in mind these are conjugates, so this is going to be 3 times r squared minus 16. You still have to distribute that. Distribute these, put it in standard form, factor it, use the quadratic formula, whatever. This one, your common denominator will be 4t times t minus 15. So again, you're going to multiply each term by this. This cancels out, this becomes 4t. Here the t cancels out, and this becomes t minus 15. Here the 4 cancels out, and this becomes t squared minus 15t. All right, you got sort of an easy one here. Again, put it in standard form, quadratic formula, factor it, whatever. If you look at the answers, it helps you decide. Again, but that's something you're going to do. Okay, number 7. Now they're changing themes a little bit because what they want you to do is to solve this particular formula for the letter V. Okay? I'll give you a little hint on that too. You want to isolate the v, so you're going to divide both sides by 8. You now have v squared equals t over 8. Okay, and let me see how they give that answer. Okay, so now all you have to do is take the square root of this side, and then I'm assuming plus or minus the square root of that side. So you get v equals plus or minus the square root of t over 8. Now, normally they don't leave an 8 in the radical. I'm sorry, in the denominator. They would have to what they call rationalize the denominator, but they're not doing that here. And I see they're only giving the non-negative value, so we can erase the negative sign there, because they said they didn't want the negative one. Now, as I looked at example 8, I said to myself, wow. But here's where our friend the quadratic formula comes into play. Suppose we rewrite that as 0 equals 3x squared plus 5y, 5x, I'm thinking y, minus y. And now you're going to identify what is A. A is 3. What is B? B is 5. And what is C? C is a negative y. So you do some substitution. And you're going to say x equals negative b, so negative 5, plus or minus b squared, which is 25. We can just write it right in there. Minus 4 times a, we said a was 3, times c, which we said was a negative y, all over 2a, which is 6. And you simplify that, and again, they said they didn't want the negative, so we can take the negative out of there. Okay? I'll let you finish that, because you do want to get some practice yourself.
Oh. Can I come in?
All right, we have Catherine Pinn, who's one of our tutors here, who's going to actually illustrate example 13, how to solve for x.
So when you're solving for x, the first thing you need to do is multiply by 3, because you need to get rid of those parentheses. So if you multiply across by 3, you get 3b equals x squared minus 2x. Then what you do is move everything to one side, and you've got 0 equals x squared minus 2x minus 3b.
I should put a 0 in there, that's good.
Got the 0.
So now it's in standard form.
And now you can do the quadratic equation on this. So your quadratic equation, x equals negative b plus or minus the square root of b squared minus 4ac. So here's your negative b, negative 2 becomes positive 2. This should be plus or minus, actually.
Well, they only want the positive
values.
values.
They only want the positive values.
Yeah,
Okay.
they said that.
So plus square root of negative, or b squared, which is negative 2 squared, minus 4 times a is 1, c is negative 3b. So you end up with 4 plus 12b. Then you can factor 4 out of this, so you get the square root of 4 times 1 plus 3b. Once you've got 4 as a factor, you can take that to the outside. So 2 square roots of 1 plus 3b. Then your 2 cancels. You've got 2 over 2 plus 2 over 2 times the square root of 1 plus 3b. So your final answer is going to be x equals 1 plus the square root of 1 plus 3b.
Well done, and thank you very much. One of our first guest lecturers. Yes, I might just add that I might have done it this way. Put this under another square root sign. So then you get the square root of 4. That's out. That's now a 2. And that's where she gets the 2, and that worked out very well. Okay. Then we're going on to example 15, where they're saying a ball is thrown downward at a speed of 15 meters per second at an altitude of 200 meters. Use this formula to estimate how long it takes the ball to reach the ground. Okay. Well, I looked at that, and again, some of this I haven't taught for a while, so I didn't quite know what it referred to. So what I did was go to the textbook, and I read over about this formula. It's only a little paragraph and one example in the textbook. And it says V sub O refers to the initial velocity. T in this equation is the time, and S is the distance. And if you read on, they show how they actually solve this equation for T using the quadratic formula. So when you do that, you then get this that I have in purple here. T is a negative V sub O, and then V sub O squared, and we're only interested in the positive value here, but this was a negative, but then eventually became a positive 19.6x divided by 9.8. So then it's a matter of putting your information into the formula. So your initial velocity of 15, that's out here, so it's going to be T is a negative 15 plus the square root of 15 squared, that's this, plus 19.6, and the distance in S is 200, and that's all divided by 9.8. So as long as you know this formula, I'm assuming the teachers will allow you to use this formula, and plugging in your information into the formula, then you get T is approximately 5 seconds. Now there are a few others, but this tape is probably running long enough. I know if I were to assign these to students, I wouldn't give them all of the examples to do. I'd give them a couple so they can get the feel of it, and that's what I've done here. So good luck, and I think we have just a couple more lessons in Chapter 8 to do.